Section 2.3 is uses of percentages in statistics. Here are our learning objectives. In a Harris interactive survey of 514 human resource professionals, 90% said that the appearance of a job applicant is very important for a good impression. What is the actual number of respondents who said this? Well, I want to figure out what 90% of 514 is. Remember that 90% as a decimal is 0.90. So if I take 0.90 times the number of human resources professionals that I have, I get 462.6. So 462.6 people said that the appearance of a job applicant is very important. Here's the issue. You can't have 0.6 of a person, okay? How come we're getting it now? Well, it could have been a rounding error when they were rounding 90%. It might not have been exactly 90%. So in this case, what we want to do is, because you can't have 0.6 of a person, we're gonna wanna go ahead and round up. We're gonna wanna round up even if we had 0.3 of a person, right? 0.3 of a person is a whole person in statistics. So we're gonna have 463 professionals who actually said that it's very important, their appearance for a good first impression. Only whole people in statistics. We can also use percentages to describe change. There's absolute and relative change. Absolute change describes the actual increase or decrease from a reference value to a new value. So our absolute change is the new value minus the reference value. The relative change, just like before when we talked about relative error, right? It is the change converted and presented as a percentage. So relative change is the new value minus the reference value, otherwise known as the absolute change, over the reference value times 100 to make it a percentage. So why don't we go ahead and work through an example. The world's population in 1950 was 2.6 billion, and by the end of 2015, ooh, that's big, that's a lot of growth, it reached 7.3 billion. Let's describe the absolute and relative change in the world population from 1950 to 2015. So our absolute change is our initial value. No, it's not. Our absolute change is our new value minus our reference value. That's going to give me 5.3 billion. My relative change is going to be my new value minus my reference value over my reference value times 100. That gives me 7.3 minus 2.6 over 2.6 times 100, which gives me 180.8%. Now in this course, unless it states otherwise, just go ahead and round to the 10th. That's my preference personally. So that's how we calculate the relative change. Other than relative change, we can take a look at a way to use percentages for comparisons. It's a little bit different, which is going to be relative difference, which we're going to get to in a second once I talk about the slide. Okay, so our reference value again is the number that we're using as a basis for comparison, right? It's the original value. And then our compared value is the other number, which we would compare to the reference value. That's the new value, essentially. The new and shiny value. New. So absolute difference is the difference between the compared value and the reference value. This is pretty much the exact same thing as absolute change and relative change. If you look at all the formulas also for relative error, it's pretty much the same formula. So that might help you remember it for homework and exams and projects and things like that. So the absolute difference is the difference between the compared value and the reference value. So absolute difference, again, is the compared value minus the reference value. And the relative difference describes the size of the absolute difference, this guy, as compared to our original reference value. And we express that as a percentage by multiplying it by 100. So why don't we go ahead and work through an example. According to the World Health Organization data, life expectancy for American men is about 76 years, while life expectancy for Russian men is about 63 years. Using the life expectancy of Russian men as the reference value, compare the life expectancy of American men with that of Russian men in absolute and relative terms. So this is going to be our comparison value, 76 years, and 63 years is our reference value. So I'm going to take, to find my absolute difference, we're going to take 76 minus 63, and we get an absolute difference of 16 years. That absolute difference is going to have a unit, or once we convert it to a percentage, for relative difference, it will not have a unit. So I'm going to take my comparison value minus my reference value over my reference value times 100, and that's going to give me the percentage for relative difference. So 76 minus 63 over 63 times 100 equals 20.6%. So that's the relative difference in life expectancies for Russian and American men is 20.6%.